So today we are working on our warm-up, and our goal is to go ahead and find the x-intercepts of these parabolas. We know that they're parabolas because our highest power is an x squared. So we can solve these two ways. We can either do a generic rectangle diamond problem, or we can do the quadratic formula. So for our first one here, we're going to go ahead and see if a generic rectangle diamond problem works. So regardless of the method, we're going to go ahead and find our A, B, and C. Our A is 2. That's the number in front of our x squared. Our B is negative 11. That is the number in front of our plane x. And our C is negative 21. So we're going to go ahead and multiply A times C. 2 times negative 21 is negative 42 for the top of our diamond problem. And our B goes on the bottom, negative 11. So now we're going to go ahead and take a look at all of the factors that make up 42. So our first one is always 1 times the number itself, and that adds to 43, subtracts to 41. And then we have 2 times 21, which adds to 23, subtracts to 19. We're going to see if 3 goes into 42 evenly, and it does. 3 times 14 is 17 or 11. And that's what we're looking for, is that 11. So we have a 3 and a 14. It needs to be a negative 11. So that's going to be 3 minus 14. Now that we have our right and left, we're going to go ahead and put our information into a generic rectangle. We go back to our original problem and we put our 2x squared in the bottom left. We put our constant from the original problem in the upper right. Now the two squares that are remaining is how I'm going to get that at negative 11x from the middle of the problem. We have a 3x minus 14x, and that's how we get our negative 11. Now it's time to go ahead and factor and find the outside of our generic rectangles. I see that I have a 2 here. It goes evenly into 14. So I'm going to take my 2x out here. That leaves me an x here to make that a 2x squared. 2x times negative 7 gives me negative 14x, and x times 3 gives me 3x. And I double check, 3 times negative 7 is 21. Now we have written this in product form. And we need to use the zero product property to find our roots, which is our final step. So we're going to set each of these equal to 0 because we know that our roots are when our y is equal to 0. And we're going to go ahead and solve. So our first x is at 7. And our second x is going to be at negative 1.5. Okay, and I know that those are my x-intercepts. Now, if I want to find the vertex next, I'm going to add them together and divide by 2. That'll be my x value, and then plug that back into the original equation to find my y. Okay, let's go ahead and use the quadratic formula for the next one. So remember, my quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So my a is 6, my b is 17, and my c is 12. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, now when we're using the quadratic formula, our next step is we start working underneath the square root. I do 2 problems. I do my 17 squared, and I multiply these 3 numbers together. Everything else we just simplify. So I have x is equal to negative 17 plus or minus the square root. 17 squared, remember we always put parentheses around this first number, will always be positive, is 289. And then our second problem is multiplying those three together. So I have a negative 4 times 6 times 12, and that's minus 288, all divided by 2 times 6 is 12. Okay, now we're still working underneath our square root here. And we have x is equal to negative 17 plus or minus the square root of 1, all divided by 12. And we know the square root of 1 is 1. So now we're ready to break this up into two answers. We have negative 17 plus 1 divided by 12, and negative 17 minus 1 divided by 12. So this gives me negative 17 plus 1, press your equal sign, divided by 12. And that is negative 1 1/3. So my first x is negative 1.33, or you could write it as negative 1 1/3. And my other one is negative 17 minus 1, set your equal sign, divided by 12. And my second root is negative 1.5. Once again, you could solve this using a generic rectangle diamond problem as well. Either one works. I just wanted to show you both methods. And that's what's cool. If most of you probably did a generic rectangle diamond problem and you saw that you were able to get the same answers even when I did it differently. So both methods do work. We're going to finish up with a generic rectangle diamond problem for this last one. A is 2, B is negative 7, and C is negative 30. So A times C, negative 60, goes up top, and B goes on the bottom, negative 7. We're going to go ahead and find our right and lefts. We have 1 times 60, which gives us 61 or 59. 2 times 30 gives us 32 or 28. 3 times 20 gives me 23 or 17. And now I'm going to start using my calculator. 60 divided by 4, does that go in evenly? We have 4 times 15, which gives us 19 or 11. Once again, I'm looking for a 7. So I'm going to try 60 divided by 5, which is 12. So 5 times 12 adds to 17, subtracts to 7. So that's what we're looking for, is our 5 and our 12. We want a negative 7, so that's going to be 5 minus 12. Now we go ahead to our generic rectangle, and we have our 2x squared in the bottom left. We have our negative 30 in the upper right, and we split our negative 7x into 5x minus 12x. I have evens going this way, so I'm going to be able to take out 2x. That makes this an x. 2x times negative 6 gets negative 12x. And x times 5 gives me 5x. So my product form is x minus 6 times 2x plus 5. I'm going to go ahead and set them both equal to 0. So I have an x minus 6 equals 0 and a 2x plus 5 equals 0. Remember, I'm going all the way to find the x-intercepts, which is also called the roots or the solutions. So I'm going to add 6 to both sides. And I have my first root at positive 6. Here, I'm going to subtract 5 from both sides. 2x is equal to negative 5. Divide both sides by 2, and x is equal to negative 2.5. And those are your roots, ladies and gentlemen. Remember, we do have multiple techniques on a test. What I'm grading is not the roots, because we know we can find that easily. What I'm grading is the work that you have in order to get to those roots. Once again, this is a review from last chapter, but this information is also on the chapter 9 test as well.